So in this case, it is given the following figure shows the front and side views of the solid. Draw the isometric position of the solid. So here, this is the one way, other way of asking the isometric position. He has given the front view and side view. You can see here. So this is the side view and this is the front view. So we need to draw the isometric projection in this position. The side view, you have to draw the isometric projection. So if you remember, so when we have started with isometric position, the basic classes, isometric position of the planes, all the three different positions we have drawn the isometric position. So one is the 30° on either side, and other one is 30° and vertical line. So all these practices we have done, correct? So now what we will do, so here you can see here from the side view and from front view, you have to see the both side view and front view, and you have to decide, okay, which is this solid and which is this solid. So by looking at this outer one, so it is in the front view, this solid I am speaking, 45 is 60. 45 is the length and 60 is the height. And from side view, we can see the thickness of that. That is, surely it is a rectangle. It's a rectangle of 45 by 15 into 60. It's a rectangular prism, a rectangular slab. So 45 and 25 is the side, and the height is 60. So this is the one solid. So coming to this solid, from the side view, we can see the length of the solid is 60, and then the height of the solid is 15. And what about this breadth? You can see this breadth here, that is 25 millimeter. So it is also a rectangular, the prism. So it is exactly, so this is one rectangle. So one more rectangle is attached here, like this. Okay, the two rectangles were formed. So like this is one rectangle. So one more rectangle is attached to this, like this. So with this, the front view and side view, you could able to find out the dimensions and the shape of the two combination of the solids. So this, the solid is rectangular prism of 45 by 15 and height is 60. And coming to this, so it's a rectangular prism of the side 15 by 25 and height is 60. Okay, both are placed perpendicular to each other. First, let me draw the isometric projection for this, the right side solid. So this solid, let me draw the isometric projection. So what is the size of this solid? It is 15 by 45 is the base and 60 is the height. See, this is the thickness and this is the length. So what you do? So to draw the isometric projection of this, you draw the horizontal line. You can observe the cursor here, and from take any one of the point, draw the isometric the 30-degree line on either side. In your grid line, already it is there. So you draw the 30-degree on either side. Now let me take the 15 millimeter, the one side of your rectangle. From this right side, cut it. The right side 30-degree line, and other side of the rectangular prism is 45. You take 45 millimeter from this as the center. You cut left side of the 30-degree line. Okay. So after this, you can draw 30-degree line on either side like this and complete the base of your rectangle. Okay. You can draw 30-degree here, and here you will going to get a rectangle here. So after this, to complete this entire solid isometric projection, what is the height of this? It is given 60. You take 60 millimeter vertical line from all the 4 points. Here also one point is there, I am not shown here. Okay, vertical line. The vertical line should be equal to isometric 60. That is the height of your the rectangular, the prism. So once you get the end of this vertical line, so then from here also you have to draw the vertical line, which is equal to 60 millimeter isometric scale. Then join all these 4 points like this. Join it. So you're going to get the top face of your rectangular prism. So if you do till here, this completes the isometric position of the right side of the solid. So this solid isometric position are completed. Okay, which is having 1545 millimeter this side, and then height is 60 millimeter. I have completed this. Okay, so till here I have understood, and then exactly at the center of this I need to place this the one more rectangle which is having 25 by 15, and the height is 60 millimeter here. Exactly at the center means, so total it is having 45, correct? Total 45, and this rectangle is having 25 millimeter side. So total 45 from the center if you want to take means how much distance I should leave on either side? It should be 10, 10, 20, 20 plus at the middle 25. So total 45 millimeter you have to get. How to draw this? So let me go to the next slide. Here you can see. So after drawing this, you can see here. So once again I'm showing here. So total this is 45. Correct? So exactly at the center I have to keep this, which is having this rectangle, which is having rectangular prism, which is having 25 millimeter side. So total 45. Exactly at the 25 means on either side 10 millimeter I should leave, from here 10 and from here 10 millimeter I should leave, and I should construct this rectangular prism. How to do this? So let me show you here. So here you can easily, so you can see, so from here, from this point, all of you listen carefully and see, observe this cursor also from this point. So you take isometric 10 millimeter, mark this point. Similarly, from here you take isometric 10 and mark this point. Okay, on either side 10 10 you are leaving it, so that I can place exactly at the center 25 millimeter. So if you measure the from here to here this distance, it is so 25 isometric scale you will going to get. So after this, what is the this thickness of the rectangle here, height? How much? 15. Now from this point 10 millimeter what you have taken, and from this point from here 10 millimeter what you have taken, you take height of 15 millimeter, isometric height of 15 millimeter, draw a vertical line. So these two lines are drawn from this point and from this point, which is equal to isometric the 15. Once you get these 2 points, join it. Join this and this point. So the complete the attached part of this rectangle is ready. So it's a rectangular prism here also. Correct? So all of you understood this. Once again I'll repeat it. You take 10 millimeter from this point, and from this end point also 10 millimeter. Mark that point. Now you take this height 15 millimeter. Take this isometric 15 millimeter vertical projector line and take this height isometric 15 millimeter from this point. Now after getting these two end points, you join it. So this rectangle is the attached the combination of solid to this solid. So after this, what is this the length of the your rectangular prism, which is given 60 millimeter, correct? So now, so how many points you are having? 1 2 3 4. From all the 4 points you draw a 30-degree line like this. Draw a 30-degree line in this direction. Once again I'll repeat, from all these 4 points you draw a 30-degree line like this, and the length of this 30-degree line should be equal to the isometric 60, which is given here, isometric 60. So you will get 1 2 3 4 points you're going to get. So once you get this 4 points, you join it 1 2 3 4, you will going to get one more rectangle here. Okay, so now the rectangular prism is ready. It is combined with this vertical rectangle. This is horizontal rectangle, this is the vertical rectangle. Both are perpendicular to each other. So this is how we have to complete this, the isometric position of this combination. At the end you can erase the your hidden edges and all, you can erase it. Only the visible edges you can show it, and even this also it should be erased. Within this it will come. Okay, exactly like this you will going to get the isometric projection of this combination. So this is how you have to do it. So this completes this the two rectangular prisms are perpendicular to each other, which are placed like this. So next so one more the different the type I have taken here. So this is almost this type we have discussed in the last class. So let me give you, we'll go a little fast this example. The following figure shows the front and top views of the solid. Draw the isometric position of the solid. So in the last class we have discussed, for example, where in rectangular slab above that one the rectangular pyramid and a square cube above that one more cube above that one the sphere. Correct. One rectangular slab above that one the cube like that. Here also almost similar to that. So here also instead of giving the dimension, he has given the front view and top view here. Okay. This is the top view and this is the front view. By looking at this front view and top view, you should be in a position to identify which is the base solid and which is the top solid. So let me teach you how to decide. So the top view is a rectangle. Correct. The base solid, the top view of the outer, so this one is a rectangle of 100 by 25, correct? It's a 100 by 25 millimeter. So sorry, it's not 25 millimeter, it is 40 here also, 40 plus 40. The inside is 25. Okay, even this is also 40 only. So which I have not mentioned here. So in the sketch it will be given. So this is 40 and this is also 40. So it's a rectangle. So 100 by 40 rectangle and height is 40. So which is this the base of the solid? It is a rectangular slab. Prism are the slab. So slab, why we call this instead of calling a rectangular prism, I will call it as a rectangular slab, and the height is small or very less. In such a case, we can call it as a slab. The height is more, we can call that as the prism. So by looking at this, the top view, this is 100 by 40 and the height of this solid is 40. So it is the rectangular slab of the 100 by 40 by 40. So 40 is the height, and at the center one more solid is kept. So here it is 25. It's a square. By looking at this, we can, it is a square and the same dimension is given here also. And the height also it is 25. So in which case all the three dimensions are same. Length, breadth and even height in cube. So that's why the top solid is a cube. So you have to understand how to draw this, the top view as well as the front view. Okay. So how to draw this the top view and front view, you know. So first you draw the outer rectangle of 100 by 40. How to draw the cube inside? You draw the that is diagonals. From the center, you draw the vertical projectors and horizontal projector passing through the center on either side. Now it is 25. 25 means from the center how much it is? 12.5. You take 12.5, 12.5 from the center, all the four lines, and then after that passing through that point you draw horizontal and vertical lines. Inside you are going to get a square. So after this, project all the points here. What is the height which is given? 40. From here you draw 40, construct this rectangle. Now you extend this cube here. What is the height which is given? 25. Construct this square. Okay, the cube will look like a square in the top view as well as in the front view. This rectangular slab look like a rectangle. The top view and front view also it look like a rectangle. Now let me draw the isometric position of the base of the solid first. So that is 100 by 40. You know how to draw it. Draw one horizontal projector line. Take any one of the point. Draw 30-degree line on either side. From this point I'll draw 100 millimeter isometric scale on the right side, and this is 40 millimeter on the left side of the 30-degree line. After this I'll draw 30-degree line in this direction, 30-degree in this direction, which I have not shown here, the base, because it is not visible. So you're going to get the rectangle like this, base of your rectangular slab. After this, so from all the 4 points, 1, 2, here also 1 point is the 2, 3, you draw the vertical projector line, which is equal to the isometric 40. You'll get 4 points, 1, 2, 3 and 4 points you're going to get. You join this 4 points. You're going to get the top face of your rectangular slab. So this completes the rectangular slab isometric position, which is having the 100 by 40 by 40. This is the dimension of the rectangular slab. So above this, I need to keep the cube. So in all the cases, both the solids should be coaxial to each other. That means exactly the center of this face I need to keep my cube. So after this, how to get the center of this, draw the diagonal line like this. Next slide, let me show you. You draw the diagonals on the top face of your rectangular slab like this. Once you get the center, you draw two mutually perpendicular lines. That is, so you draw from here, you draw a parallel line to this longer side, and from this point you draw this line parallel to the shorter side. So two parallel lines passing through this center you have to draw. Now what is the size of your cube? The cube is having 25 millimeters. Half of that from the center, if you take, it should be half of that. How much I should take? 12.5. You take isometric 12.5 from the center. This point you're going to get from here, this point, from here, this point, from here, this point. So 4 end points you're going to get. From this, passing through these 4 points, you draw the parallel line once again. From this point, after getting this point, you draw a parallel line to this line. Similarly, from this point, you draw a parallel line to this. Similarly, from this point, you draw a parallel line to this. From this point, you draw a parallel line to this like this. So after drawing these lines, whichever the inside the rectangle, square, whatever you are getting it. So this is your base of your cube. So the base of the cube is constructed exactly at the center of the rectangular slab. Once you complete this, the rest of the things, it is very easy. So what is the height of your cube? It is isometric 25 only. So from all these 4 points, 1, 2, 3, 4 points, you draw a vertical line which is equal to isometric 25. How to draw it? Like this. See? Draw the vertical line which is equal to 25 millimeter, that is isometric 25 millimeter. Once you get those vertical line, you join it. 1, 2, 3, 4. So now, this is the combination of the two solids which are kept one above the other. The base solid is the rectangular slab. The top solid is a cube. At the end, you can remove those lines. You can see here, whichever the line which I have shown with the light lines. Okay, you can remove those lines so that only you can see the visible edges. So this how you have to complete this combination of the solids. Next example, let me take a different one. This is very simple. It looks very simple because in 2 steps you are going to get this. So you have drawn the pentagon prism. You have drawn the pentagon prism. Just you construct the pentagon prism. Above that, a sphere is placed. That is what it is given in the question. So what is the question? A sphere of diameter 50 millimeter rests centrally over a pentagonal prism of side 40 millimeter and height 70 millimeter. This is what the two solids which are given. So the base solid is pentagon prism. Above that, the sphere or the ball is placed. So how to draw the top view and front view? So first you draw the base solid, that is a pentagon prism. Pentagon prism, when you see from the top, it look like a pentagon only, either edge or corner condition. So it is left to you. You draw the pentagon first. Okay. After drawing the pentagon, you enclose the pentagon within a box like this. After doing this, how to find out the center of the pentagon? Bisect any two line and join it to the corner. So you're going to get the center of this pentagon. Now your sphere, how it looks? The sphere will look like a circle, either in the front view or top view, in whichever the angle. That's what I told in the last class also. The sphere is the only solid. Okay, in whichever the angle, if you see either front view, top view, or even the side view on either side, it look like a circle only. And also only for the sphere, even in the isometric projection, you need to take the actual length only, actual dimension only, not the isometric dimension. For all other the dimension that we have to take for other the objects, it is isometric scale. So from So after finding out the center, so what is the diameter of your sphere? 50. You take 25 millimeter radius and draw the circle passing through this center and draw a circle. So this is your the top view. Okay. And front view, your pentagon prism look like a rectangle. You draw the vertical projector from all the points. What is the height of the pentagon is prism is given 70. Construct the rectangle like this. Now above the center line you can extend from here. This is the center line you can extend. Now you take the radius, that is height of the sphere, 25 millimeter you take. Now after taking 25 millimeter, this is the center and 25 millimeter is the radius, you draw the circle. So this completes your the front view also. Now we will concentrate on how to draw the isometric position of this combination of solid. So first, as usual, draw the horizontal line. You take any one of the point here and draw 30-degree line on either side. So after that, let me draw a isometric position for the outer box first. Okay, you measure this distance and this distance, convert that into isometric the length. This is the center, you cut an arc on the right side, and this is the center, cut an arc the left side of your 30-degree line. And from here you draw 30-degree line and parallel line to this, and from here you draw 30-degree line left side or parallel line to this, so that the outer rectangular box you can draw the isometric projection. Okay, so after this you identify these points, this points in between this box, and construct the pentagon, the base. You know how to draw the pentagon, so you construct the corresponding points within this the rectangle and join all the 5 points. You will going to get the base of the pentagon prism. So base of the pentagon prism is ready. So how to complete the pentagon prism? So in the previous, only if it is only a pentagon prism, so directly what would have done? You would have draw the vertical line from all the 5 points like this, which is equal to the height of the pentagon, and we would have joined it. And we need to find out the center of the top face of your pentagon also. For that, what we will do? First, I will draw the vertical projector from all this, the corners of your rectangular box first, which is equal to 70 millimeter. So let me show you in the next sketch like this. I draw a vertical line from all the 4 corners of your rectangular box like this, which is equal to 70 millimeter. Now you join these 4 points, so you're going to get one more rectangle here box you're going to get. Okay, so to get the top face of your pentagon, either what you have done, you can do it the same corresponding points in all this the sides, you can mark it and then you can join it. Or else the other method what we were following when we were drawing isometric version of the prisms, from this 5 points of your pentagon, you draw the vertical projector of same height, that is 70 millimeter height. So definitely, so we're going to get on this, exactly on this, the outer box only. So you can join it, all these things. So now your pentagon prism is ready now. So I think all of you understood this. So why I have taken this outer box also? To find out the center. That is the only reason. So now how to find out the center? Draw the diagonals for the outer box. So this is your center. Correct? So after finding out the center, you need to draw the vertical line. You need to draw the vertical line which is equal to isometric, the height of your sphere. So what is the height of the sphere? 25 millimeter. That is, radius is nothing but height of the sphere. So take isometric 25 in this vertical line. So let me show you in the next. You take isometric 25 from the center. Now after identifying this point, now actual radius, that is 25 millimeters the radius, that is a sphere. From this center you draw the circle. You draw the circle from this center, actual radius. So your sphere is ready, which is placed above your pentagon prism like this. So this how you have to complete the pentagon prism, above that the sphere is placed. So by remove at the end you have to remove all the knotted lines, construction line as well as the hidden edges. You have to remove it. At the end you can see exactly it will look like this. So here all the construction line as well as the hidden edges are removed. So this is the final isometric position of your two combination of solids wherein pentagon prism above that sphere is placed. Okay, so this is one. This is very simple, and for this also in the examination test 30 marks. It's a 30 marks question, so easily you can get it. Next, one more last example for today's class we'll discuss. So which is this. A cone we have not discussed last class, correct? One example of cone we'll discuss today. So what exactly it does? A cone of base diameter 50 millimeter and height 60 millimeter rests centrally over a square slab. Square slab of 70 by 70 millimeter and height 25 millimeter. So this is what the dimension which has given, that is a base solid is a square slab or square prism. Told you why it is called slab, because the thickness is less, and above that a cone is placed centrally. So the square slab, how it looks in the top view, it look like a square only. So that's why you first draw the square of 70 millimeter. First you draw the square of 70 millimeter in the top view, because the square slab look like a square in the top view. Now, and the cone, how it looks in the top view, you see the cone from the top, it look like a circle, correct? So how to find out the center of the your square? Draw the diagonals, get the intersection. So that is your center of your square. Now from this center you draw a circle of radius 25 millimeter. The top view is ready. Now coming to the front view, you draw the vertical projectors from this end point, and from this point also you draw the vertical projector line, and your square slab in the front view it look like a rectangle. So that's what is the height of the rectangle is given 25 millimeter. You take 25 millimeter, construct this rectangle. Similarly, the cone height is given how much? 60 millimeter. The cone when it is seen from the front side, so it look like the isosceles triangle. So from here you take 60 millimeter, and from the center you draw a vertical line. So wherever this 60 millimeter line cuts, you mark it. This is the vertex or the apex of your cone. Okay. So now you join this like this. So your cone will look like a isosceles triangle in the front view. So this how we have to construct the front view and top view. Now we'll come back to the isometric projection. So base solid is a square slab which is having a 70 by 70 the side, base side, and the height is 25 millimeter. So you know how to draw the square slab. So rectangle, square slab, in many examples we have discussed. You draw an horizontal line, take any one point, draw the 30-degree line on either side, and what is the base side of the square prism slab is given 70 millimeter. You take isometric 70 millimeter and cut on either side of your the 30-degree line. Cut on either side of the 30-degree line like this, here and here. Now you draw the 30-degree line on either side. You will going to get the base of your rectangular the slab. Now after this, what is the height of the rectangular the square slab? 25 millimeter. You draw a vertical line which is equal to the isometric height of your this slab. It is 25 millimeter. You are going to get 1, 2, 3, 4 points. Now you join these 4 points. So your the isometric version of the square slab is ready like this. Okay, so these lines we cannot see, that's why the light line I have drawn. So above this we need to place the cone exactly at the center. How to find out the center of the top face of your square slab? We need to draw the diagonals. If I draw this diagonals, so that I can get the center of your the square slab. So like this, you can draw the center the diagonal, so that I can get the center like this. Now in many cases we have done. So how to draw the base of your the cone. Okay, so now from this center you draw a parallel line to these two edges from the center. Similarly, you draw a parallel line to these two edges. Like this, you can draw a parallel lines. That's all. Now from this center, so what is the diameter of your cone? It is how much? 50 millimeter. Correct? The diameter of that it is 50 millimeter. How much I will going to get on either side? How much? It is 50 millimeter. How much it is given? Let me see. The cone 50 millimeter diameter. Correct. So you take half of the 50 millimeter means 25 millimeter. From this center, you take 25 millimeter on this line, 25 millimeter on this line, this side, and 25 millimeter here and 25 millimeter here. So on all the four lines which are drawn parallel lines passing through the center, you have to take 25 millimeter. So you will get 1, 2, 3, 4 points you will get. After getting those 4 points, now from this point you draw a parallel line to this, and from this point you draw a line parallel to this, and from this point you draw a line parallel to this edge, and from this point you draw a line parallel to this. So after drawing those lines, you will going to get the inside the base, that is a square base, whatever you are getting it. So this is the base of your the cone. Now within this I need to draw the ellipse, that is in isometric position the base of the cone look like an ellipse. So after completion of this, next step what you have to do, so you have to draw a ellipse within this the square. By 4 center method we have followed it, correct? So from here what you have to do, draw a line exactly at the midpoint of these two points. Similarly, from here you draw a line exactly midpoint of this line, and then from this corner you draw a line midpoint to this, and from the same point you draw a line midpoint to this line. So after drawing it, how many points you are getting? 1, 2, and this intersection 4, and this intersection 3, and this is 4. 4 points you are going to get. Take your compass now. This as the center, either this or this as the radius. You draw an arc. Similarly, from this as the center, either this or this as the radius, you draw one more arc. Now, from this intersection as the center, either this or this as the radius, you draw an arc in this fashion. And from this intersection as the center, either this or this as the radius, you draw one more arc. So, you will going to get an ellipse like this. After getting this ellipse, that is the base of your the cone is ready now. So from the center, what is the height of the cone which is given? 60 millimeter, right? You draw a vertical line from the center which is equal to isometric 60 height of the cone like this. Next, let me show you in the next slide. You can see from this center, you draw a vertical line which is equal to the isometric. The height of the cone, that is 60 millimeter, isometric 60. So this is your the vertex or the apex of your the cone. Now from this point, you draw a line or draw a tangent to this ellipse on either side from here to here. If you do this, so this almost completes your the isometric question of the combination of this the particular case where the square slab is the base solid, above that centrally the cone is placed. At the end you can see, after removing all the your the construction lines and all other hidden edges, so this is the combination of the isometric the projection of this will going to get. So here also the same the method or the procedure we have followed here. So I hope you have understood this also. So let me take some samples. So any doubts you can So any doubts?